because you're going to use it so much. But please know that it is all in your quencher. And I think I spelled my quencher wrong here. But anyway, you guys know what I mean. So let's try solving some problems. So here's my gas law calculations number 1. We always know that I start with this formula all the time. P2 V2 over N2 T2. And over here is my before and after. So I know that I had 2 liters of gas. So before my volume 1 is 2.00 liter of gas at this pressure. So pressure P1 must equal 740.0 millimeters of Hg. And what is the new volume? So I'm actually looking for V2 at standard pressure, and I know that standard pressure is 760 millimeters of Hg. And it says no mention of the number of moles or temperature, and so we're going to assume that these are constant. So if I assume that number of moles and temperature are constant, I can cancel these out. And so now I have P1 times V1 equals P2 times pi V2. So here is my P1, 740.0 millimeters of Hg, times by V1, which is 2.00 liter, is equal to V2 times by, which is something that I don't know and I want to figure out, 760 millimeters of Hg is my P2. I'm going to divide by 760 millimeters of Hg, divide by 760 millimeters of Hg, and I know that the millimeters of Hg cancel out. The only unit that I have left is my V2, so my V2 must equal 1.95 liter, and that is my answer. To go into a second example, I have a gas that is collected and found to fill that much volume at this temperature. What will be its volume at the standard temperature? So here is my before, here's my after. Before, the volume is 2.85 liter, and my temperature is 25.0 degrees Celsius, and my volume is my after volume. Well, V2 is what I'm looking for, and I want the temperature to be at 0 degrees Celsius, which is my standard temperature. Please remember that you never do temperature in Celsius. You gotta add 273 to it, add 273 to it, and now your new temperature is 298 degree Kelvin and 273 Kelvin. So now going back to my original formula, you have P1. So what are my constants? My constants are pressure and the number of moles, because there is no mention of them changing. So these are my constant, which tells me that I can actually cancel those out and cancel that out. And my V2 is 2.85 liter. V1 is 2.85 liter. My T1 is 298 Kelvin, which is equal to V2, which is my question, and that is my Kelvin. Alright, so now I want to isolate V2. V2 must equal 2.61 liter, and please note, after you do these calculations, you might want to kind of pause and say, well, my temperature increased, and so my temperature decreased, so my volume should also decrease, because they are one on top of the other. So it's a direct relationship. I should see a decrease in both sides, both numerator and denominator. A weather balloon on Earth's surface has a volume of this much at this temperature and this pressure. If the balloon is released and the volume reaches this volume at this pressure, what is the temperature in degrees of Celsius? Oh, I gave you the answer here. I'm sorry. So over here, I'm going to start again with P1 V1 over T1 N1 is equal to P2 V2 T2 N2. And over here, I have volume. V1 equals 4.00 liter. Again, this is before. This is after. My temperature is at 31 degrees Celsius, and I'm going to add 273 to that, and that gets to 304 Kelvin. And my pressure is at 755 millimeters of Hg. My volume 2 is 4.08 liters, and my temperature is what I am looking for. And my pressure 2 is 728 millimeters of Hg. There is no mention of number of moles, so this must be constant, and so I can actually take that out of the equation. So my P1 is 755 millimeters of Hg times by volume 1, which is 4.00 liter, over T1, which is 304 K, is equal to, let's see, pressure 2, 728 millimeters of Hg, times by volume 2, which is 4.08 liters, over T2, which is what I'm looking for. And the temperature comes out to be. Before I talk about the temperature T2, I want to address some of the really often made mistakes in honors chemistry. Please remember that T1 is in the denominator, so if you do this calculation, please make sure that you make your T2 a numerator T. So I'm actually going to cross multiply here, and so I am going to get 755 millimeters of Hg times by 4.00 liters times by T2 equals 728 millimeters of Hg times by 4.08 liter times by 304 K. So now my T2 is going to equal, it equals to be about 299 Kelvin minus 273 from that, and you get 26 degrees Celsius. And that is your answer. If you might want to try this calculation and make sure you don't bump into that mistake. Whenever the T2 is in the bottom, you might want to just cross multiply, make it into a numerator, and then divide these out. So what is the pressure exerted by 32 grams of O2 in 20 liters of container and at this temperature? So now I'm not really comparing before and after. I just have a situation where I have volume is 20 liter and my temperature is 30 degrees Celsius, which I'm going to add 273 to, which gets me 303 Kelvin. And I know that looking at the periodic table, under oxygen, it says 16.00 here, which means that 1 mole of oxygen equals 16.00, but this is not oxygen O, it is actually O2, meaning that I have 2 of these. So that comes out to be 1 mole of oxygen, O2, actually equals 32 grams. Okay? So now I know that I have 1 mole of O2, which is 32 grams. So in other words, I have my number of moles, which is 1 mole of O2. So I'm not comparing before and after, so I'm going to use my my ideal gas law, which is my P1 V1 over N1 T1 equals R. And so I am looking for pressure. P1 is what I'm looking for, but I know R. I know my 3 R's from the 3rd page of my cruncher and also from this slide. So here is my R in ATM, here's my R in kPa, and here's my R in millimeters of Hg, and they are also in the 3rd page of your cruncher. So let's say that I want to find P, and so P must equal R times by N times by T over V. So if I want my P in ATM, I'm going to use the R, which is 0.0821 liter times by ATM over mole K, and I'm going to times this R by 1 mole of oxygen. I'm also going to multiply this by 303 Kelvin, and I'm also going to divide all of this by volume, which is my 20 liters. My liters cancel out, my moles cancel out, my Kelvin also cancel out, and then I get my 1 unit, which is in ATM. And my P is going to equal 1.24 ATM, and I think I am at, how many sig figs do I have? Because of this number, I only have 1 sig fig. Sorry, I wasn't supposed to put that there. About 1 ATM is what I have.